Hi, and welcome to our first lecture video, Chapter 1, Functions, Limits, and Rates of Change, Section 1.1, Introduction to Functions and Relations. And just to point out, I do teach these topics in a review format, algebra topics, and if you'd like to delve into any of them more, there is all sorts of supplemental material available. See the other links for that information. So we'll start right in. What is a function? What do you remember? And when I do this in a classroom class, we get all sorts of things that come up. Some of the things that people remember are words like domain and range, sometimes also called inputs and outputs. Oops, let's see if I can spell right. Some people remember notation, f of x, all right, that kind of notation, f of x is how we read that notation. Some people bring up the word linear, which is a particular kind of function, which we will in fact focus on very much this semester. Lines, linear functions will be very important to us. Some people recall the vertical line test. We'll remember what that is as well. We'll go over that. So those are a lot of the things that people come up with. Maybe you're thinking of other things. Oh, graphs. Those are important. Ordered pairs. Sometimes those are what people call out in our classroom situation. All right, so we'll talk about pretty much all of this stuff. So underneath here, I say definition. This is out of our book, page 5. A function is a rule that pairs each element in one set called the domain with exactly one element from a second set called the range. And I didn't bold it, but these words exactly one, those are super important. So I am going to underline them, called the range. So each input, which is a domain element, gets mapped to exactly one output, which is a range element. Sorry, I'm not perfect with my digital writing. So we can use ordered pairs, x, comma, y, to show input-output pairs. A graph is a picture of a collection of ordered pairs. So there we've talked about a lot of stuff already. So the graph of a function will pass what we call the vertical line test if a vertical line, which is up and down, crosses a graph more than once. The function fails the vertical line test and is not a function. So this first example from page 19, number 10, we're looking at this backwards S kind of a graph. And we can see actually the y-axis is a vertical line. And if I look closely at that y-axis, vertical line, I do see that it crosses the function in 3 places. So right there, there is an example, and it just takes one of this function to failing. It fails the vertical line test. And so this one is not a function. And we could have drawn other vertical lines to see that as well. In our second graph, number 11, we see what you might remember is called a parabola. It's upward U shape. And if you try to draw some vertical lines on this graph, you're not ever going to be able to find one that crosses this graph more than once. Right? Each vertical line crosses at just one point. So this one passes the vertical line test. And this is a function. All right, so that's our basic introduction, this vertical line test, thinking visually. Let's continue on a little bit on this video. So the next thing, now that we have functions, we learn how to evaluate them. So we evaluate a function. I don't want you to know that word, so you'll know that that's the instruction to do what we're about to do. We evaluate a function when we plug in any given values and calculate the result. So here's some examples. Given our function g of x equals x squared plus 3x plus 4, evaluate the following. So number 24, g of 2 And I always like it when people take a step to show the plugin. And then absolutely use your calculator, do one step to get the number. I don't need to see the arithmetic, but I would like to see the plug-in steps. So I might write for my first step, g of 2 would equal that 2 squared. And I like to color code also because I can, so I'm going to be doing that a lot. So 2, there's my 2 being squared. Here I am also plugging in the 2 for the x next to the 3. So there's 2 x's in the original function g. So 2 goes in for both of those, and then we add 4. Then we do need to know order of operations. 2 times 2, I'll write this one out because it's our first example. 2 squared is 4. Then in the middle, 3 times 2 is 6, plus another 4 at the end. 8 and 6 or 10 and 4 is 14 for our final answer. Our final answer is a number. Plug a number in, we generally get a number out. Second example, number 20, g of negative 2. So working with a negative, we want to just, again, let's get everybody on the same page. When we plug in the negative 2, the parentheses here are actually essential to make sure we square the entire negative 2. We really want to take the entire negative 2 times another negative 2. Our calculators don't even know that we want to include the negative when we want to square negative 2. So be super careful with that. And then again, 3 times now this time the negative 2 plus the 4. And so when I square negative 2, I again get a positive 4. But then in the middle, 3 times negative 2 is negative 6. So I'm going to subtract 6 and then add 4. So this time we just get negative 2 plus 4 is positive 2 for our answer. All right, see if you can play around with your calculator. Do know that on the calculator, there is a subtraction button and there's also a negative button. If you're not familiar with that, it's usually a button, either the negative button might look like a plus minus on your calculator. On the TI 83s, 84s, it looks like a little negative in parentheses. It's down at the bottom of the calculator. Do ask about these things if you have any trouble, but it's different from the subtraction button. Okay. And now number 28, this adds a new twist. We're not just plugging in a number, we're plugging in this expression, a plus 6, where a is some variable. We don't know what it stands for. So we can still show the plug-in step where I need to plug in that entire a plus 6 and square it. And then in the middle, I got to take 3 times that entire a plus 6. So here, more than ever, parentheses are absolutely essential. Then I add the 4 at the end. So how do I work this out? First of all, recognizing a plus 6 squared is not as instant as a squared plus 36. It means to take the entire a plus 6 times another a plus 6. Okay, and so working that out, we're going to get, oops, look at my blue, we're going to FOIL. We will get an a squared, but then we get an a times 6, which is 6a from the outer terms there, and we get another a times 6 or 6a, and then we do get that 36 at the end. So we get the a squared and the 36, but there's some other stuff as well, and I'll come back and combine those. In the middle, we get a 3 times the a, and we get a 3 times the 6. You might remember that as being the process of distributing. So we're going to distribute there in the middle and get 3a plus 18, still plus that 4 at the end. Now I need to combine like terms. Again, some of you, this is like old hat. Fast forward through this if you like, totally fine. But if this is a good review for you, then remember you can always stop, go back, watch things over again, and ask lots of questions. Always good. So let's work on combining like terms. The a squared is the only a squared in the whole problem, so that'll just stay by itself. Now if I scan for a terms, I've got a 6a plus another 6a, that's 12, plus the 3a from the middle. That's 12 plus 3, that would be 15 copies of a. And then for my numbers, I've got a 36 and an 18. That's 54 plus another 4 is 58. And we're not going to do a whole lot of the reverse kind of factoring on something like this, so we can just pretty much leave this as is for now. I'm not going to worry about changing anything there. But that's our final answer then, a squared plus 15a plus 58. typically if we plug something in that's not just numbers, we get out something that's not just numbers. And I'm going to end this part 1 here, and we'll come back on and work on part 2.